How's it, grade 11s? We're going on to equations of tangents and normals. I'm working from this chapter in your book, 25, equations of tangents and normals, and then I will do these examples at the bottom here. Okay, so as you guys know, a tangent is a straight line that touches a curve at one point, okay? So we know how to work out a tangent because it touches at one point. We can use calculus to find the gradient and etc. But now here's a new thing, which is the normal. Now the normal is perpendicular to the tangent, all right? And it also goes through that point of contact. So what we can do there is a relationship between the tangent and the normal because they are perpendicular. And this comes from your analytical geometry. We know that the gradient of the tangent multiplied by the gradient of the normal will be equal to -1. Now, how does that help us? Well, we can find the gradient of a tangent, finding the derivative, okay? Then all we have to do is use this property, and then we can find the gradient of the normal, and then we can find the equation of a normal. So that is basically what we're going to do in this section here. So for example 1, it says determine the equations of the tangent and the normal to this graph. F of x equals x cubed minus 2x squared plus 4 at the point 2, 4. Okay, so what I'm going to do first is focus on the tangent. Now, because a tangent is a straight line, it will have the equation y is equal to mx plus c. And what we need to do is we need to find out what is the m value and what is the c value. Now, to find the gradient at a point, we're going to have to use calculus. So I know that the gradient of the tangent would be equal to f dashed of x, okay, the derivative of the original one. So if we find the derivative there, we get 3x squared minus 4x. Okay, so that is your derivative function or your gradient function. But we're interested in a particular point, which is this here. This is our point of contact. And remember that this has a coordinate, so it's an x and a y value. All I do is I take my x value, put it in here, and then that will give me the gradient at this point. So the gradient of the tangent would be equal to 3 times 2 squared minus 4 times 2. Okay, so that gives us 4, that's 12. 12 minus 8 is 4. So we know that the gradient of the tangent is equal to 4. All right, so therefore what do we have? We have y is equal to 4x plus c, because I've got that m value now. All I have to do now is find that c value, and in order to do that, I substitute my point of contact in. So we're going to substitute this 2, 4 in. So that is y is 4 equals 4 times 2 plus c. So that means that c is equal to, that gives us 8. So 4 minus 8 is minus 4. Okay. Therefore, the equation of the tangent, y is equal to 4x minus 4. So that's the gradient of the tangent. Now, we can move on to the equation for the normal. And as you can see, the normal is also a straight line. So y is equal to mx plus c. We need to find the m value and the c value. Now, this is where I'm going to use this property here. We already know what the gradient of the tangent is. So I can go straight into the gradient of the normal. And all we have to do, grade 11s, is invert this gradient. So if I invert it, it becomes 1 over 4. But then I need to change the sign. Okay, so it becomes -1 over 4. And that's all this. All right, so now we know we have y is equal to -1 over 4x plus c. In order to find the c value, I substitute our point of contact in, so 2 and 4. And we get 4 is equal to -1/4 times 2 plus c. So this will give us a half. So it's 4 plus a half, and we get c is equal to 9 over 2. Therefore, the equation of the normal is y is equal to -1 over 4x plus 9 over 2. All right. Okay, so moving on to example 2. Okay, example 2 is saying determine the equation of the normal to the parabola y is equal to 4x squared at the point x is equal to minus 1. Okay, so we are not interested in finding the equation of the tangent, just the normal. First of all, grade 11s, I do not have the point of contact. I have half of it. So we only know that x is equal to minus 1. What I need to do is I need to find out the y value. So all I do is I take this, put it back into the original, and we get y is equal to 4 times minus 1 squared. So we get y is equal to 4. Therefore, the point of contact is minus 1, 4. Okay. Right, so in order to find the equation of the normal, y is equal to mx plus c, I need to find the gradient of the tangent first. Okay, once I've got the gradient of the tangent, I can use this property that we used in the previous question. Okay, so I find the gradient of the tangent, then I can find the gradient of the normal. Okay, so m tan will be equal to, if I differentiate this, I get 8x, but we're interested in this point of contact, so m tan is equal to 8 times minus 1, so the gradient of the tangent is equal to minus 8. Therefore, the gradient of the normal will be equal to, I invert this, so it'll become 1 over 8, and I change the sign, so it just stays positive. Okay, so now we have the gradient of the normal. So y is equal to 1 over 8, I'm just substituting it in here, x plus c. Now we need to find that c value, and all I do for that is I substitute this point in, so minus 1, 4, and we get 4 is equal to 1 over 8 times minus 1 plus c. So that'll give us minus 1 over 8, take it to the other side, and we get 4 plus 1 over 8. And that gives us 33 over 8. So we get c is equal to 33 over 8. Therefore, the equation of this normal will be y is equal to 1 over 8 x plus 33 over 8. All right. Now, going on to example 3. This is 2 parts. So part A, it's saying here, at which point is the tangent to the curve? So we've got this main curve, g of x equals x cubed plus 5. Okay, so at which point is the tangent to this curve parallel to this line? 12x minus y equals 17. So we need to find the point of contact where the tangent to this curve is parallel to this line. Now remember, if lines are parallel, so if we have parallel lines, the property for parallel lines is m1 equals m2. So the one gradient is equal to the other gradient. What I need to do with this one here is I need to get it into the form y is equal to mx plus c. Because once I've got it in that form, then I can get my gradient. Once I've got this gradient, then I can know the gradient for the other one. Then I can use this, the derivative of this, to find the point of contact. So I'm just going to get this into this form. So take the y to that side, the 17 to the side, and we get y is equal to 12x minus 17. Okay, so therefore m1 is equal to 12. There it is there. That means, therefore, the gradient of this tangent is also equal to 12. They have to be because they are parallel. Now I need to find the point of contact. So I know what the gradient is, all right? So what I'm going to do is I'm going to differentiate this function here. So g dashed of x will be equal to the gradient of our tangent. So the derivative of this will give us 3x squared plus 0 equals 12. And what I can do now is I can solve for this. So if I divide by 3, I get x squared is equal to 4. So x squared minus 4 is equal to 0. You can factorize this, x plus 2 minus 2. And we get x is equal to minus 2 or x is equal to 2. All right. Now, we've got our two x values where we'll get a gradient of 12. I need to take these two, put it back into the original to find out what the y values are. So we've got g of minus 2 will be minus 2 cubed plus 5. The other one, g of 2 is equal to 2 cubed plus 5. So g of minus 2 is equal to, that'll give us minus 8. Minus 8 plus 5 is minus 3. That's 8. 8 plus 5 is 13. So the one point of contact is minus 2 minus 3. The other one is 2 and 13. All right. Going on to part B. So again, we still got this main function g of x is equal to x cubed plus 5. And in part B, they're saying, at which point is the tangent to the curve, this curve, perpendicular to the line x plus 3y equal to 2. Okay, I need to get this into the form y is equal to mx plus c. So we get y is equal to minus 1 over 3x plus 2 over 3. So grade 11, so all I did is I just took the x to the other side, it becomes a minus. Then I divide through by 3. Yes, I know it'll be x over 3, but I prefer it to be 1 over 3 because then I can read off the gradient. Okay, so therefore m1 is equal to minus 1 over 3. Okay, so with this question here, they're saying that the line needs to be perpendicular to this point here. Okay, now if it's perpendicular, you remember our property m1 times m2 equals minus 1. Therefore, m2 must be equal to, if I invert this and then change the sign. And that is the gradient I'm looking at because they are perpendicular. m1 times m2 equals minus 1. Okay, so now that I have the gradient, I'm going to differentiate that and set that equal to this. So we've got g dashed of x equals m2. So g dashed is 3x squared plus 0 is equal to 3. All right, divide 3 by the 3. Take this to this side, and we have a difference of 2 squares. So factorize this, equals 0, and we get x plus 1, x minus 1. So x is equal to minus 1, or x is equal to 1. I need to take these x values, put it back into the original to find the y values. So g of minus 1 will be equal to minus 1 cubed plus 5. G of 1 will be equal to 1 cubed plus 5. That gives us minus 1 plus 4. So g of minus 1 is 4. And then g of 1, this will give us 1 plus 5 is 6. Therefore, the point of contact where it's perpendicular will be minus 1, 4. And the other one will be 1, 6. Okay. Right, guys, last example. Example 3. Example 4. Right, it says here, determine the equation of the tangent to the curve f of x equals 2x plus 1 over x minus 3 at the point x is equal to 2. So we need to find the equation of the tangent to this curve when x is 2. Now, remember we need a point of contact. So what I need to do first is I need to find out what my y value is, just by substituting this in here. So we get f of 2 is equal to 2 times 2 plus 1 over 2 minus 3. Okay, so at the top we get 4 plus 1 is 5 over minus 1. Therefore, this point of contact is 2 minus 5. All right, so what we need to do now is we now need to find the gradient, okay? Because y is equal to mx plus c. That's the equation of a tangent. I need to find the m and I need to find the c. So I need to differentiate this. So m tan will be equal to f dashed of x. Now, grade 11s, because we have two terms in the bottom, we must use the quotient rule, okay? So this will be equal to, and what we do is we differentiate the top, leave the bottom, minus, leave the top, differentiate the bottom, all over the denominator squared. Okay, now I'm not too interested about simplifying this. All I'm going to do is I'm going to substitute x being 2 into this thing, and this will give us the gradient. So we get 2 times 2 minus 3 minus 2 times 2 plus 1 times 1 all over 2 minus 3 squared. Okay, so if we work this out, we should get that this is minus 7. So the gradient of the tangent is minus 7. So we get y is equal to minus 7x plus c. I know what my m value is now. To find the c value, we substitute in our point of contact, which we worked out over here. So minus 5 equals minus 7 times 2 plus c. That gives us minus 14. Take it to the other side, and we get minus 5 plus 14, so c is equal to 9. Therefore, the equation of this tangent is y is equal to minus 7x plus 9. All right, guys. So what I want you guys to do for me now is you guys can do this exercise for me here. 1 to 6, please. Thank you.